Good morning, everybody. It is June 3rd. We're almost done. So, gosh, only like 5 more days of this, and I'll stop recording. I'll be done on Friday, and then the last 3 days will be things for you to get caught up. If you are caught up, and if you have everything in, you will get an A, okay? Awesome. Just have to get everything in. You'll have an A regardless. If you don't have everything in, then you will not get an A, period, okay? So, you better get stuff in. Be really cool, okay? And some of you will get incompletes. And an incomplete is really a bummer, because with an incomplete, of course, the kids that are not watching this are probably the same kids that are getting incomplete. So anyway, most of you who are watching this are getting A's. Good job. Okay, so today's lesson, first of all, let's correct the homework. This is what I got from yesterday. The cosine of 24 over 25 has got to be angle, the cosine, no, it's angle F. That's angle F. That's a mistake. The sine is angle E, because if you do the decimal of it turns out to be 0.38. 3 is about 11.5 degrees. 4 is 45 degrees. 5 is 70.7 degrees. 6 is at 62.9 degrees. 7, when you solve it, this side is a 13.4. You can use Pythagorean's theorem actually to get that. Then you can either tangent inverse to get either one of these angles. You get one and then subtract from 90 to get the other. Same thing here. You can use Pythagorean's theorem to get the 72. And then you can either use, probably I would have used sine inverse to get the 16.3 and then get the other from 90. Right? Just 90 minus 16.3 gives you the other angle. On this one, we got to go back to what we did the day before. You've got the angle, so you set it up probably using sine to get the side. I'd go sine of 52 equals x over 3. Get the angle and subtract from 90. And then you can use Pythagorean's theorem to get the other side. On this angle, again, it's what we did the day before. I'd probably use sine to get this angle or tangent to get this side. And then once I get this side, I can subtract from 90 to get 61. 11. Probably going to use sine inverse of 12 over 25, get a 28.7. Okay, I wish we were in class, because trig is something I really like to teach, and it's not that hard if we were together. So, well, we'll do it again next year in Algebra 2, I promise, okay? All right, so today, let's go through it. Today I want to talk about story problems, because trig is used in our society a lot, okay? So, anywhere you can see a right triangle, you can use trig. Okay, so angle of elevation. So if you look at the horizon, here's my notes today. If you look at the horizon, and that's going straight across, right, flat, then any angle that comes up from the horizon is called the angle of elevation. Okay, now there's another angle here, but we don't even want to talk about this. We want to the angle of elevation. Okay, so let's look at example 1. A 6-foot man sights the angle of elevation to the top of a building to be 64 degrees. If he's 100 feet away, how tall is the building? So, first of all, this is right triangle trig. So let's draw a picture. Always draw a picture. We know that we're going to need a right triangle somewhere, okay? So let's draw a picture. Here's my 6-foot man. He sights a building, so he's kind of standing here, you know, just chilling. And then here's the building, right? He sights the building. Now, the right triangle we're looking for is actually elevated 6 feet, because it's 6-foot men, right? We know this is 6 feet. So we find the height of the building, we'll add in the 6 feet. Hopefully that makes sense. So he sights the building to be 64 degrees. He's 100 feet away, so this is 100, which means that this is also 100. Okay, well, here's how trig works. Go to the angle you know. Here's my angle, right? When I go to my angle, then I have to look at what I know. I know this side, and that's my adjacent side, because it's next to me. And then what I want to find is x, which is my opposite side, right? Throw the rock to the opposite side, okay? So opposite adjacent, well, let's check it out. Let's write these down so we have them. So I'm going to look at them. Sine of any angle is the opposite over the hypotenuse. We know cosine of any angle is equal to the adjacent over the hypotenuse. And we know that tangent of any angle is equal to the opposite over the adjacent. Okay, and we have these in my classroom right above where I'd be recording, but of course we're not there. So anyway, what we have is opposite adjacent, opposite adjacent. We want to find the opposite. Here's the adjacent. Opposite adjacent, opposite adjacent, opposite adjacent. There it is, tangent. So we're going to use tangent. So we're going to go tangent of theta. Okay, so we're going to go tangent of theta, but theta is 64 degrees because theta is always the angle, right? So tangent of 64 is equal to, let's see, it's equal to the opposite side, on opposite over the adjacent. So it's the x over the 100. Okay, now to solve for x, I'll just take the 100. Now I'll multiply it up here, multiply both sides by 100, and I get 100 tangent of 64 equals x, and I'm going to use my calculator. If you have your phone will work, but a calculator is so much better. So I'm just going to go 100 times the tangent of 64. I get an answer about 205, I assume, feet. Yes. So it's about 205 feet. Okay. Now, we got to make sure that we add in the 6 feet. So we're going to add in the 6 feet, and we get 211 feet. That's how tall the building is. 211. Okay. Easy. Okay, again, check your mode. Hopefully that makes sense. You need to be in degree mode. Okay, angle depression. Well, angle depression's, the horizon's up here. Here's the angle depression. Here's my horizon. And the angle of depression is the angle that goes down, okay? There's theta. Now this one's confusing sometimes because sometimes kids think that's the angle of depression, but it's not. It's always from the horizon down, okay? From the horizon down. So, example 2. An airplane flies at an altitude of 5,000 meters and begins to descend to the airport at an angle of depression of 10 degrees. How far is the plane from the airport? So let's draw a picture, okay? Remember, we need a right triangle. So here's my little airplane. Again, Mr. Davies is not much of an artist. And it's flying down at an angle of depression of 10 degrees. Okay, see how it works? Here's my horizon, my angle of depression of 10 degrees. Okay, the airplane is 5,000 meters above the air. It makes its descent. Okay, here's my airport way over here. Okay, here's my little airport. Tower. So it's heading down that way. Now, we also have a second triangle since we have the angle of depression. So the second triangle is here. Okay, these two triangles are congruent. So this 5,000 is also over here. Since these two triangles are congruent, then I also have a 10 degrees here. So I can use either triangle. I can use the blue triangle, or I can use the red triangle. May as well use the blue triangle, looks easier. And I want to know how far the airplane is from the airport. That would be right here. Okay, the airplane from the airport, not the ground speed. It would say the ground distance. Okay, so let's see. I have my angle, and way over here is the opposite side. This is my hypotenuse. Okay. Let's check it out. Opposite hypotenuse, there it is, sine. Opposite hypotenuse, sine, opposite hypotenuse. So let's set up sine of 10 degrees equals, because theta is 10 degrees, sine of theta is equal to the opposite, which is 5,000 over x, which is hypotenuse. Now, one of the variables on the bottom, we're going to have to multiply, then divide. So I multiply it by the x, brings the x here. So I get x times the sine of 10 equals 5,000. Sine of 10 is a number, so I actually divide by sine of 10, divide by sine of 10. Now, what is that in my calculator? Let's find out. Just going to go 5,000 divided by sine of 10. Okay, and what do I get? About 28,000, which makes sense because the airplane's a long ways away. 28,794, about. We'll round up. 28,794 meters. We're about 28 kilometers away, right? There you go, CC. About 28. This is for CC. Or 28 kilometers away, right? because we can do metrics, right? 28.8 kilometers. There you go. That's for CC. Okay, moving on. Metrics, you guys. It's much better. Problem 3. Find the area and perimeter of an isosceles triangle whose vertex angle is 40 degrees and base of 12. So let's draw a triangle, okay? Area and perimeter. Isosceles triangle. Okay, let's draw an isosceles triangle. We know that the vertex angle is 40 degrees and the base is 12. Well, I don't see a right triangle, but this is right triangle trig. But that's easy. We'll just make one. Okay. Need a right triangle? There's my right triangle right there. So let me superimpose that triangle down here so we can use a right triangle. Alright, so this is 6 because it took half of this, and that's 20 degrees. Now, if I need both the area and perimeter, to get the perimeter, let's find this side first. Let's call this A, okay? And we'll find this, we'll call this H for the height of the triangle, okay? So, first of all, let's take a look at this. I'm going to have 20. I look all the way across, that's my opposite. And that's my hypotenuse. Opposite hypotenuse, opposite hypotenuse, opposite hypotenuse. Got to be sine, right? So we'll set up sine of theta. In this case, theta is 20 degrees, not 40, but 20 because we're using this angle, this triangle. So I'm going to set it up. I'm going to go sine of theta, or sine of 20, is equal to my opposite, right? Opposite over hypotenuse, 6 over A. And again, our last problem we showed how we just bring up the A and divide by 20, so I'll just do it in one step. Bring up the A, and I'll divide by the sine of 20, save myself a little time, and I'll just use my calculator, okay? Alright, let's go ahead and do that. Let's go 6 divided by sine of 20, and I get an answer of about 11.5. Okay, so this side's 11.5, this side's 11.5, and then what I can do is, for the perimeter, it's going to simply be, well, let's see. It's going to be 11.5 plus 11.5 plus 12, because perimeter is all the way around. And let's see what I do, okay? Oh, 17.5. Shoot. Might be nice if I could see, huh? Wasn't blind, huh? Okay, so let's go 17.5 plus 17.5 plus 12, and I get an answer of about 47. So the perimeter of this is about 47 centimeters. Okay, now the area. Well, let's go back. Let's find the height. Now that's my adjacent, okay? Yes, you can use Pythagorean's theorem to get it, but I'm just going to use trig. It's a little more accurate, okay? So that's my adjacent. I'm going to then use my opposite. I don't need the hypotenuse, so I've got opposite adjacent. That's tangent to find the height. So I'll set up tangent of theta, right? Opposite adjacent is tangent. Opposite adjacent is tangent. So I'll go opposite of adjacent, so I'll go tangent of 20 is equal to my 6 over my h. And again, same thing, if the h is on the bottom, we'll multiply by h and divide by the tangent of 20. Let's do that all in one step. H is equal to 6 divided by tangent of 20, okay? And I'll just use my calculator. 6 divided by tangent of 20. Again, if I'm going too fast, just pause the video. 16.5 about, so the height is about 16.5. So the area of any triangle is equal to 1/2 base, which is 12, times the height, which is 16.5. Let's see what I get for an answer. Okay, so I'm going to go 1/2 times 12 times 16.5, and I get an answer about 99, and that would be in terms of centimeters squared. Okay, all right, last but not least, okay, I'm going to go through this one with you. It's a great problem. So area of the regular pentagon. So before I do anything, let's just take a look at the fact if it's regular, there are 5 triangles, and each of the triangles are all equal to each other. Okay, so let's just look at this one here. Here's what I know about this one here in blue. This angle has to be 72 degrees because out of 360 degrees around a circle, divide that by 5, I get 72 degrees. So you should 72, 72, 72, 72, 72, okay? But I need a right triangle, right? So what I'm going to do is drop my altitude down, and let's look at this triangle, okay? So let's look at the blue triangle. Okay, now why am I doing this? Well, I need to find the area of one of these triangles, okay? This is 36 degrees, half of that, and this is 5, and that's the right triangle, okay? So if I need to find the area, what I've got to do is find the height, okay? The height of this triangle. Well, let's do the same thing we just did. Opposite, right? From here, opposite and adjacent, right? This is my rock through the opposite side. That's my hypotenuse, so I don't need it. Opposite adjacent, opposite adjacent, opposite adjacent, tangent. So set up tangent again. Tangent of theta, but theta is 36 degrees. Tangent of 36 is equal to 5 over h. We'll multiply by h, and then we'll divide by tangent of 36. So h is whatever 5 divided by tangent of 36 happens to be. Okay, use my calculator. Okay, on. Okay, 5 times tangent of 36, and I get an answer of about 3.6. So the height is 3.6. So let's go back over here. 3.6, the height of that triangle, okay? Or 3.6. Okay, so how to find the area of a triangle? So first of all, area of a triangle, right? 1/2 base times height. It's going to give you just one triangle, okay? Just use my calculator, okay? I'm going to go 0.5 times 10 times 3.6, and I get about 18. So the area of one triangle is about 18, but there are 1, 2, 3, 4, 5 triangles, all of the same area. So the pentagon is going to be 18 times 5. 18 times 5, I get an answer of about 90, and that's in terms of, well, let's just say centimeters squared. Okay, now homework is actually going to be a worksheet, and if you guys need a copy of it, you can, but what I would do is look at it real quickly and just do it, okay? And here, this pentagon, solve this right triangle, okay? 2, solve this triangle, okay? 3, it's going to be another isosceles triangle. 24, it's a 5-foot boy, sights a tree, and 25, the submarine takes a dive. So it's going to be a, it's going down, it's going to have a angle of depression. So go ahead and take a look at this. This is your homework for today. If you need a copy of this, you can ask and I'll send it to you, or you can just take it straight from the review, okay? Or from the film. I will talk to you again tomorrow. You guys have a great day. Get this done, please.